Hey everybody, this is Gary, the consultant that was in the other day. All right, just in case what I didn't sink in completely, I wanted to go over again really quick everything that we covered. All right, so first off, we talked about the responsibilities of a Linux admin or a system admin, and one of the first of those being installing an operating system. We're not going to go too much into that right now or demonstrate that. The next thing we covered is networking, and networking you're going to get later on, but just as a preview, if you type in if config, and by the way, I've got a mechanical keyboard on here, so it's super loud. Apologize for that. Type in ifconfig or ipconfig on a Windows machine. You'll see over on the left-hand side a list of all of the adapters, network adapters, things that allow network connectivity to this particular computer. Ignoring the word wraps that we see right there, we just see three adapters on this Raspberry Pi: ETH0, Loopback, and WLAN. For this particular one that I'm plugged into, I actually have two addresses associated with it. With the physical connection, I have 192.168.1.248. So this is a hard Ethernet cable that's plugged into my Pi directly from my home router. And then down there at the bottom, it also has a wireless connection on 192.168.1.250. Kind of in a bigger sense, something that you could recognize from this is the fact that different network cards can actually be on completely different networks, and thereby kind of bridge between different places that it can communicate with. Okay, next thing we talked about was users and groups, and the fact that we need to add users to machines and modify them. If I want to add a user to this one, I can type in, well, okay, let's just first see what's on there. So if I type cat etc password, we see a list of users that are on here. And so from class the other day, we have people that added users like your mom, Gary the goat, Jacob. Wow, looks like quite a number of people needed to jump on there and create accounts compared to what I was aware of. So it's all good. Some of the things about this are that the first field is your user account name, and then the 1, 2, 3 after so the third option there is the user ID associated with that name if it was a number, and then the fourth one is the group number associated with that user. Over here is the person's default folder that they're going to have associated with their account. Then lastly is the shell associated with their login. Technically, there's different types of terminal windows with commands that are available. You can set different ones. I noticed just now that while I logged into my Mac, and it said now we want you to use Z shell instead of bash or something like that. So yeah, there's a few out there. That's the Linux world. There's always like 5 different ways or more to do every single thing that you can possibly do. So get used to that. Okay, the passwords for this would be in cat etc shadow, but this won't work because you have to use the sudo to do special things or things that are probably locked down on a machine. So cat etc shadow. Oops. Someone in class did that too. All right. So sorry about the word wraps on here, but technically, if you were to pull out each distinct line, the long part of that is the hashed password. And the way that works is your actual password doesn't get saved on the machine. It gets run through an algorithm. So you enter in your password like isrocks, and it runs it through a hash and checks if that matches this hash right here. And if it is, then it logs you in. Okay, so just like all the users that are on there already, let's go ahead and add a user. So I type in user add, and I'll call him Dagan K. And it says user permission denied, cannot lock. I don't know why that is right now. This is going to mess up my video. All right. Anyway, so I added a user, and if I click up a couple of times to see the contents of my password file, we should see that the Dagan K file is there at the end. Great. So, but we did not give that person a password. So to do that, we go sudo password Dagan K, and then it'll ask me what I want to put in there. And to make this easy, I will just do DEGANK, because that way I don't have to think about it. And I just typed it in wrong. There we go. Okay, so now I could actually log in as this user if I want. I could type in switch user, Dagan K, and I type in Dagan K, and I am that user. To get out of that user, I type in exit, and then I drop back to the Pi user again. All right, another thing we want to talk about is the file system. So I'm going to type in clear, because I like to keep my place clean. So ls/ls gives me a listing of whatever's in the directory that I specify. If I don't specify something like the /, then it will just show me my current directory. All right, so right now I'm looking at the home directory, kind of like the C drive, the root directory of my operating system, and there's everything in blue here. They're not always highlighted in blue, but everything that you see there in blue is a folder because of the profile settings associated with my login right now. If we go out there and we Google something like file systems basics on tutorial point, it'll give us a web page that shows us what kinds of things are by standard in each of the folders that you see there. So one of them is bin, and if we look up bin, we'll see that it contains the applications that are typically used from the command line and are available to all users. So if I type in ls bin, we see a bunch of commands there. We see things like cat, and we see things like ls. So anyway, you get the idea. All right, what else do I want to talk about? Another thing in there is cd etc. So in etc, there's a whole bunch of things that end with .conf. One of the things that's contained in the etc folder, in addition to password, meaning the users, is other configuration files, oftentimes ending in .conf. And if you look at the contents of them, it looks like a programming language, and that programming language is called bash. So you do bash scripting, and you typically do administrative stuff. Things like we're doing already, adding and deleting users, and later on we'll do things like check log files, all that kind of stuff that can be done with bash scripting. If one of the things I wanted to highlight is like rc.local and everything that starts with rc, as well as init.d, wherever that is on the page up there. There's another one too, I believe systemd is a way to, all three of these are going to be ways that we can add things to the startup of our system. So once you have created some software that you want to run whenever the machine is on, for example, if you wrote some custom Python code to run your electronics, what you would do is you would drop in a bash script that does the startup. And so there's just a bunch of redundant places that you can put your startup information into, but if there's a startup command to start your program, you drop it into one of those places, and then every time your computer reboots, it will start up your application again for you. So that's quite important. Okay, another thing that you want to be concerned about related to the file system is how much space you're using. So if I type in df-h, this is equivalent to disk-free, human readable, and we see that on the /, the root of our system, that we have 12 gigs available, and 6.5 of it's used, 4.8 of it's not used. The key issue here is that if you have thousands of servers running, you need to keep on top of this. Historically, once you hit 100% and things start overwriting existing data, applications start overwriting existing data, sometimes your server crashes and it does not come back up again. So that can be a serious issue if that's customer data and it's gone forever. Okay, another thing that we want to talk about is navigating around. So cd change directory is a way we can do that. So cd / cd tilde, cd with nothing. / starts us at the root directory, and then we can descend anywhere we want to go from there. So we go like cd / bin, and now we're in the bin, as you can see highlighted in blue. Cd tilde, that drops us into our user directory, our default directory for our user when we log in. So if I type in pwd, present working directory, it shows that I'm in home Pi, because that's the user that I am. I'm currently Pi. All right, another thing to talk about is managing access to our folders. So let's see what kind of folders we have here. Okay, lots of secret folders have been created. So let me just make another one. Make dir secret 2. Okay, if I type in ls hyphen, well, if I do ls hyphen a, that shows, in addition to all the other folders, things that begin with a dot, which means it's hidden. It doesn't mean you can't use it. You just have to type in ls hyphen a to see all the hidden files that you don't need all the time. If I do ls hyphen l, I see permissions related to each of my items. So usually we don't think of permissions at this deep of a level, but if I go to if I look at secret 2 here, we can see when it was created, how big it is, the user associated with that folder, the owner of it really, the group associated with owning that folder, and then we see over here something starts with a D, and that means it's a directory or a folder. The things that are not directories, if we look farther up right here, it has a hyphen. So this is just a plain old text file, or this is just a plain old text file because it's got a hyphen there. Usually things aren't highlighted in blue and bold like you see here. This is just kind of an advancement that more modern computers are giving us. Usually it's all just plain text, and you would differentiate things using like the D that's out there. Okay, so back to secret 2 again. Okay, so there are 9 characters there, and each of those represent the permissions associated with this folder, or if it were a file, it'd be the same thing. So read, write, execute. That means, so the first 3 characters mean that the owner of the file, which is pi, can read, write, and execute to that folder. The next 3 characters stand for the permissions associated with the group that owns that folder, and this one can read, but it cannot execute any programs associated with this. And then lastly, these 3 things are for anyone who is neither the owner of the file nor a member of the group that owns the file. So just some random user who happens to be logged in. Or even hypothetically, if you have a program running, Apache runs under the user Apache. Apache is considered world in terms of a user for permissions, and so Apache itself could read from this file currently as given. Okay, so how can we change our permissions on there? We use chmod, and if I can go 770, oops, what am I changing? I'm going to do secret 2. Okay, so now we see that we have no permissions there. So why is 0 associated with those last 3 characters? Well, in terms of creating the permissions, a 4 represents read, a 2 represents write, and a 1 represents execute. So as I chmod something and I create some sequence of characters like 761 or 760 or whatever, you can just use the math based on those 2 numbers to know what permissions you're assigning to that particular folder or file. Okay, good enough. Well, if I spend a little bit longer, okay, let's just do let's demonstrate how this works. So I'm going to switch user to Dagan K. Okay, so now I'm that new user. He can see the secret 2 folder, but can he get into it? No, he cannot. Permission denied, because he's in that world group and the current permissions is 0 for them. Okay, so next thing we should talk about is how to edit files in on a Linux system or a Unix type system. So one of the things we can do is nano, and so I'll do temp.txt, or doesn't matter. All right, so in here, hello world, and of what I say. All right, good enough. So I've written some things down. So it kind of works like you'd expect any editor. You can go up and down with your arrows, or left and right with your arrows. And then when I'm done doing things, down at the bottom you see $O, which means write, Control O, and then I hit return, and then I want to exit this thing now, so I do Control X, and now I'm out. Another thing you can do is use VI, so I'll use VI temp.txt. By the way, I can just hit tab to autocomplete anything. All right, so there it is. So right now I'm in command mode, so I can use characters like J and K to go up and down, or I can use L and H to go left and right. So that's in command mode. Can't remember if arrows work here too. It looks like they do, but no use using the arrows. All right, now, so I'm in command mode right now. If I type in something I didn't talk about in class. I'll say O, that drops me down to the next line, and puts me into insert mode. Normally you just type I and that puts you in insert mode, but I wanted to go down to the next line. So I'll say here is some more text. Let's just say 1 million lines. Okay, that's not really grammatically correct, but whatever. And then I'll say tacos. All right, so I'm still in insert mode. I'm typing. I hit escape. And now I want to navigate around in here. Let's just say that this thing is 1,000,000 lines long, and I want to find the word tacos. I could do / TACOS, and it brings me to there. So while at first it seems that nano is much better, later on something like this is better. So VI is more powerful. If I do, let's see, switch tacos with donuts. Says I couldn't find it. Okay, I must have done something wrong in the way that I typed that. Let's see. Oh, well, I think here, let me just try that one more time. Switch tacos with donuts. Oh, man. Okay, I don't know what I did wrong there, but something close to that usually does my find replace. So anyway, so be it. Sorry I messed that one up. We could just quickly Google that and find out what's wrong, but I'm not going to do that right now. Okay, so at any rate, so if I do right quit, I'm out. And now let's go on to some other topics of interest. Another thing we need to be concerned about are all the processes that are running on a machine. So just like we don't want our disk usage to get out of control, we don't want our processes to get out of control, and inevitably they do. So when nobody's using it, like when you're developing, nothing goes wrong. In production, everybody that's in operation knows that things are going wrong constantly. That's what it means to be under load. Okay, so if I type in top, I see all kinds of things like how much memory is being used currently by my machine, how much memory is in swap. If you start swapping application memory into disk because you've used up more memory and RAM than there is available in the actual RAM, usually things slow down dramatically, and so that's a bad thing. If you've ever heard your hard drive on a computer start going as you switch between tabs or applications, what it is you've opened up too many things and it's archived some of your application data into swap memory. Means it's put it onto the hard drive and it's not in RAM anymore, and it brings it back out of RAM, which is a slow process. On old computers you can hear the metal platters spinning and grinding as it pulls that data back out. Another thing that you can look for on here are the applications that are running. So over here, let's see, I have the VNC server running currently, and I have the Minecraft game running currently. Over on the left-hand side, we can see who opened it. So root means it just kind of, in this case, that it came up with the operating system. But with Pi, that means I actually had my logged-in user open that. And every single program that's running has a process ID associated with it. And one of the reasons why that's handy is that you can then interact with that process via its process ID number. And sometimes you'll see the same command appear a bunch of times, but with different process ID numbers. You can also see how long the process has been running, how much CPU it's using. So whenever I'm debugging a problem, oftentimes I'm seeing like a program that has been written has hit max like 100% CPU on my machine, and it's bogging the whole thing down. And so then I have to take it down. Speaking of that, let's just say that my Minecraft game is causing a problem because it's using a massive amount of CPU or something to that effect. I can actually take this program down using its process ID. So to get out of here, I'm going to hit Q, but I'm going to remember this number 6332, and then I'm going to say kill -9 6332, and I actually have this open in another window. So there's Minecraft running. Let's go ahead and kill it, and having done that, it immediately vanished. Okay, and then if I type in top again, we will not see Minecraft is the third option in my list anymore. So I guess I could go kill some other things if I wanted, but let's not be too mean to my operating system today. Another way to look at our process, now the problem with this is this isn't very good for reporting. This is a real-time view, an interactive view. I could hit certain keystrokes and it'll do all kinds of fun things and sort the data in different ways. But that isn't very good for reporting, just for real-time analysis. If I want to look at my files after the fact, get a snapshot in time, I can type ps. PS just shows me what's being run by my user. If I type in PSAUX, like all users, then it will show it this way, PSAUX. Here's another way of looking at all the processes that are running. So you can see by the process IDs that these are all different processes that they're distinct and they're all running. So there's a bunch of, so I just ran this 3 different ways. And so maybe one question we might be asking at this point is, well, how do we know what the different parameters mean? So that brings up the idea of man pages. So and that doesn't mean like masculine, but manual. So if I type man and then any command that you saw like in that bin folder, for example, it will bring up the man page for that, and it will. So you can also Google, but typically all the documentation is right there for you. So if I just go up and down on my man page, I'll see examples of what to do and what the commands mean. So I did PS, it says see every process on the system, and so it says, so you can do PS, AXU, or AUX, doesn't really matter the order there, but for every command there are lots of different switches or parameters that you could add to them that do different things. If you think about it in a way, it's actually kind of overwhelming. So that's why oftentimes we end up Googling things and just copy and pasting what we see there. But really, for every single command, there are a lot of different ways that you can use them. I can't believe I'm still scrolling. Okay, whew. All right, I don't want to know that much about PS today. But if I were working, doing a full-time job on this right now, I might mess with that. All right, so what happens if I wanted to see this after the fact? Well, one thing I can do is I can just save this out to a text file. So I'll get a snapshot in time. So I can use this greater than symbol to redirect the output. So rather than outputting to the screen, let's output it to a file. So I'll output it to my file.txt, and maybe I could put a date on there if I was doing this programmatically and running it like once an hour. So I do that. All right, so now everything's been saved out to that text file. If I type in ls, I see somewhere I should see my file up there at the top, .txt. Okay, let's see what's in there. So I use cat, my file.txt, and it's in there, but that's an awful lot of stuff. So that brings up a different issue, like how do I not have so much stuff go by at the same time? Well, there's a command instead of cat that we can use, and that's called less. Actually, I'll use it differently. Nah, I'll get to it later. Sorry, I'm throwing you off. Wait, I've got some other commands to run later that'll be useful for. Okay, so I'll come back to this whole idea of limiting my input to later on. Okay, another thing we want to worry about is managing software on there. So let's see what is installed on this particular machine. So advanced packaging tool list. This is going to momentarily show me all of the programs that are installed on here. So if I'm the Linux admin, I'm responsible for, on all of my thousands of machines, every single thing that's there. Is it up to date? Is it out of date? Etc. If I need to find a particular item, so let's near the end here, we see ZZUF is a program that it's installed, so or a library that's installed. One way that we can not have so much stuff come through the screen and well, okay, a different way to say this is, what if we're looking for just a single thing? Like we want to know, is Apache installed? Is ZZUF installed? Well, we can use something called grep, which means global regular expressions. It just means given a block of text, can I find a word in it? So if I type in apt list like we just did, here's the pipe command. I'm going to take the output of one command and send it to another command. So grep ZZUF. Okay, well, we won't care about that so much. But when all was said and done, it actually did what I wanted it to do. It returned everything that had that in there. I'm just curious, what if I did something else? Like, why? Let's try the word zipper, because I see that in there a bunch. Okay, so we see 3 things that match zipper. So grep is one of those commands that an admin would be using all of the time. All right, so if I wanted to update the packages on here, the programs, I would type apt update, but I don't need to do that right now. And technically, I would do sudo apt update. All right, here's where it gets awesome. How about we install a web server? So sudo apt install Apache 2, yes. Now, Do I expect you to memorize this command? No. This is just the kind of thing you look up. You'd say, Google, how to install Apache on Raspberry Pi. And you get this command back and you do that. Okay, so hopefully it doesn't bark at us and complain too much, but it will install using it. Well, okay, let's talk about packaging tools for a second. We can see it's downloading a whole bunch of things. One of the nice things behind the idea of packages is that any given program you install may be reliant on other things. So as part of a package and using a packaging tool such as apt or yum or rpm for Red Hat Package Manager if using Red Hat Linux, these package managers enable us to download the associated libraries or dependencies with a particular program that we want to install. Okay, so hopefully it did install. I didn't check this ahead of time, but I think it installed right now. Let's see if it did what I wanted it to do. wget localhost. All right, I think it worked. Hold on a second. Let's open up a web browser on here. See if it worked. I should have tested this ahead of time. I actually copied and pasted my notes from previous weeks without verifying things. So localhost. Yes! Okay, so what we have here is we in just one line of code we installed, well, it's not really code, but just with one line of command we installed Apache web server on here. So if we find the appropriate file folder within our system, we will be able to change the pages that are here. Here's another thing that's going to be kind of fun, but may sound a little bit insane. So it said saving, so I assume that it means that it brought it down and saved it to my hard drive, that particular command. So similar to how I did like a redirect of the process command earlier, this wget just saves it to a file. So there it is. I did cat index.html, so the wget command works that way. So I could go out to the web and type in any URL and just grab that. Okay, here's another thing we could do. We could get there's actually something, instead of a visual browser from the command prompt, we can actually install web browsers that work there, which sounds a little bit insane, but okay, sudo apt get install links. Like all things in Linux, there are many programs that will do the same thing. This is going to be a web browser for us. And I will say yes. Hopefully it doesn't take too long. So hopefully what you're waiting for right now is, what does a text-based web browser look like? So I type in links localhost to see what's installed here locally. And there it is. It just makes some assumptions about what's on the page and certain decisions. And so, so amazingly, I can move around with keystrokes and see basically everything that would be on a page. It basically strips out all the graphics and leaves you with the text and the links. And for a lot of cases, that's all you really need. So that's like super cool. So I'll do Q, and I'm out of there. Okay. I am down to my last item that I want to talk about for system administration, and that is monitoring your system logs. As you get traffic throughout the day, you want to know what happened, where the traffic came from, if there are errors, what the problems are, etc. So let us look at something. The files are one of the files that we have is in var log. Let's see. Actually, var log has a lot of stuff. ls var log. Okay, so here's a number of different logs that are currently being created. And let's look at boot log, which would be a log of things that have happened. Sudo, while we're booting up, sudo var log boot.log. And, okay, I forgot something there, didn't I? Okay, so things scrolled a little bit too fast for me. So the one way we can deal with too much text scrolling by, well, of course, we could kind of go up and down, but sometimes you have thousands of pages of information, and that's just not really practical. So we use the command called less. So I'll go sudo less var log boot.log. That's kind of ugly. Anyway, I think there's a better way we could do that because it replaced some of the characters that were on the page with escape. But essentially, the content is there. So just for demonstration purposes, that is how it works. Oftentimes, if I were doing like an LS and it was going to go over multiple screens or something, that's how I might do it. And usually, it's not quite that ugly. Sorry about that. Another thing that we do is we look at the beginning or the end of a file, particularly logs. And oftentimes we actually don't care about what happened maybe 2 days ago, especially if there's millions of records. Maybe we want to know, especially as we're developing, what just happened in the last couple of minutes. And so we can use something called the tail command. So sudo tail, and I can give it a number, like give me the last 20 lines in var log boot.log. Okay, so if I did that appropriately, then it should have just shown, okay, it started right there. So I got just the last 20 lines. Another command we can use is head. So we can get head would give us the first certain number of lines in a text file that we want. Okay, so that's a crash course in all of the basics related to Linux system administration. Here is a file that I have shared with the class. So we covered all this stuff: ifconfig, cat, superuser, disk free, make directory, chmod, nano, vi, top, kill, ps, man, advanced packaging tool, redirecting our output with to a text file or piping to another file, wget, links, less, tail. Another thing in here that I didn't say this time is touch. So let's just do that one. It simply creates a file without putting anything into it. So I'll say touch my file.txt, and if I hit ls, that should be created in there somewhere. Okay, so good enough. That's all we had for today. Thank you for your patience, and I hope you learned a lot. Good luck.